We have 19 billion pounds of steel we recycle or we bring into our recycling yards and get into our mills every single year. 19 billion pounds. I mean, it's a staggering start. And as you look at what we do with that, we transform it as effectively and as efficiently as can be done in ways that are just transformational, using technology that is second to none, that is as modern gets. And we produce this product that is literally embedded in everything people touch and feel and see every single day.
I wanted to dive into infrastructure because you realize real quick that the infrastructure of a nation completely depends on recycled metal. And the infrastructure of a country begins with rebar because you can't build any structure without rebar. AT&T Stadium, the home of the Dallas Cowboys. 22,000 tons of rebar went into the making of that stadium. This is a marvel. You really get a sense of the magnitude of construction projects when you're standing right in front of AT&T Stadium. And then you realize what it took to build that stadium. I'm here at AT&T Stadium, home of the Dallas Cowboys, arguably one of the most iconic stadiums in America today. Have you ever stopped to wonder how a facility like this is made? From the parking lot, to the columns, to the staircase, to the press box, to the locker room? Well, there's one essential item that is required to build a stadium of this magnitude. And that element is rebar, which just so happens to be made from recycled iron. And then the sense of pride that I got, it's our industry, the recycled materials industry that supplies the raw material to the steel mills that we saw in Seguin and that we saw in Durant, Oklahoma, that makes the rebar, that makes it possible to build that stadium. Recycled materials industry supplying the steel mill, and we're here in a micro mill at CMC, and this is steel making, and this is repurposed. Let there be light. So this trip, when I think about it from beginning to end, was more like a 10 to 11 day trip. It first started in Washington, D.C., where we interviewed Michael Zmyslansky, talking about image and talking about how words matter.
And what often happens is you go out and communicate and people don't like your message, or they don't understand your message, or they don't believe your message because they don't know you the way that you know you.
And then we flew into Texas. There we were on a 7-day crazy road trip of filming and interviewing. It was incredibly fun, incredibly busy, and so productive. It was a great, one of the best 7 days I ever had. Day one started in Dallas at the Commercial Metals corporate headquarters. We're all excited to go there to meet the Peter Matt, the president, Ty Garrison, and all the different leaders in their organization, to sit down with them and do all the interviews and discussing Commercial Metals' role in the industry that we are in, the role in the products that they produce, and how it matters to all of us.
We serve so many different end markets that there are a lot of interesting applications, but The ones that I think are super interesting are the ones that go into some of the defense applications. So, if you look at our impact metals, which will be made from plates that are made from recycled material, we will make that into body armor that protects our troops.
So we finished the interviews in Dallas, and all right, it's late afternoon, get in the car, drive an hour and a half up to Durant, Oklahoma. So day 2, Saturday morning, we wake up again. First thing in the morning, we're at the steel mill. 7 o'clock, we're ready to rock. We're ready to take the tour. We're ready to learn about what is a micro mill.
I'm very proud to say that CMC was the first steel company in the world to start using the micro mill technology. We co-developed it with the manufacturer back in 2009. We built and started operating that first micro mill in Mesa, Arizona. And what that mill does is obviously it streamlines the steel process and makes it one continuous process. And by doing that, it further innovates on the already very efficient mini mill EAF process, and it reduces energy consumption by 30%. And in addition to that, it reduces the CO2 emissions from the production process by almost 40%.
My name is Keith Lindemolder. I'm the Corporate Sustainability Manager here at our Irving, Texas office.
Our industry is known for sustainability because of the circular nature of it, taking recycled iron, getting it to a EAF steel mill, making new products from it. Tell us about what we know about the reduction of greenhouse gases in our industry from using recycled iron to steel making.
Sure. As opposed to using iron ore as a major input, as a raw material, using scrap eliminates the greenhouse gas emissions that come from mining that iron, that come from processing that iron before it can get into the furnace itself. So using scrap has zero greenhouse gas input itself. Certainly the energy that we use, and whether it be natural gas, electricity, or any kind of carbon we inject into the furnace, has a footprint associated with it. And we spend enormous amount of time and energy trying to figure out how to do that as efficiently as possible to reduce our greenhouse gas footprint.
Tell us about a breakthrough for an example so people can understand who watch Repurposed, this docuseries. What are these breakthroughs when you see, oh boy, we could do this to reduce energy?
Sure. Commercializing the electric arc furnace back in the 1960s was a huge breakthrough. Prior to that, the only way to make steel generally was open hearth furnace or basic oxygen furnace. Now with the electric arc furnace, that was a major change. Electrifying that process instead of using fossil fuels and using electricity directly to melt the steel was a major breakthrough. Since that time, there's been continuous improvement, not only in the mini mill process like we typically see and like many of our mills are, but also in the continuous process of the micro mill application.
So instead of a billet that is made in most of the steel mills and then it go into a reheater, heat it up, and then be made into product, this goes from molten steel into a caster that's casting material that makes rebar. And it doesn't stop. There's no reheating, it's just continuous. And you see from molten steel all the way into the spools of rebar. And this is going on 24/7.
I'm Steve Simpson, and I'm the Senior Vice President of the North American Steel Group at CMC.
This is technology that is really saving our planet that needs to be celebrated. Tell us more about that.
Yeah, so maybe I'll take a little bit of a step back in time. So we used a blast furnace, or what we call DOF steel making, and that was the only technology we knew at the turn of the century. And as we progress and as we move forward, we now can take the recycled scrap in either micro or mini mills, and we can produce them at an 80% lower energy consumption than the steel that was made 100 years ago. So we are transforming, and every single day we're investing in technologies in our melt shops. We're investing in technologies in our rolling mills and our reheat furnaces that continue to lower the consumption of energy in the production of steel.
We are taking scrap metal, recycled metal, repurposed metal, and giving it brand new life.
This is steel making. This is their highways, their hospitals, their airports, their bridges, their stadiums. I mean, their driveways with the rebar that's going into the foundation to skyscrapers. Hospitals can't be made without this.
So we finished there in Durant, get in the car, back down to Dallas, get on a plane, we fly to Seguin on Saturday evening. So Sunday morning, bright and early, boom, we're there at the Seguin steel mill of commercial metal. Well, it's a mini mill, but it's big. It's 80,000 ton a month of melting capacity. And there on that site, they have a mega shredder shredding metals, and they also receive prepared recycled metal to feed into the charge buckets at the steel mill. Massive operation. So after we're seeing the metal being processed on site and the trucks being received and they're stockpiling, we go and we actually watch, again, to me, what's just incredible. It's something I could watch for a long time. I haven't got it out of my system yet. I could watch more. But the actual making of steel. Seeing it being charged from magnets from rail cars and trucks into the furnace buckets. To see the electrodes go into the furnace. And seeing the big flame from the charge and the sparks, and knowing that furnace has the molten steel in it.
My name is Sabre Serino. I work as a process engineer, and I've been employed with CMC since June of 2014.
Coolest job in all the steel mill, correct?
Absolutely. It is the highlight of the shop for sure.
So the first time you saw that in a melt shop, did you say, this is where I want to work?
Oh, absolutely. My first time going in for my interview, I remember thinking, I know what's going to happen. Like I've messed with molten metal, I've done brass, I've done aluminum. Like I know what this is. You get in there and you see that charge bucket drop for the first time. That is like the moment I was like, I am doing this. Like I want some of this.
In the steel mill, you have all that plume of smoke drifting up into the top of the building. And then what happens is that top of that building is designed to capture all that fume. And then there is a suction, like a vacuum, sucking lots of CFM, cubic feet per minute. Of air, volume of air. And then all of that suction goes in that big pipe to the bag house, or the bag house has all these vacuum bags in it where the dust is separated from the air and the clean air goes out and the dust is collected in the bags.
But then you take a look outside and you never once see smoke or emissions coming from the mill. And that's a testimony to the environmental stewardship that CMC has in their steelmaking process. I mean, you're right there, and I got to be up close and personal with steelmaking, like I did in season 1 at SSAB. Sabra, the young lady who runs the melt shop, asked us if we wanted to watch a ladle being pulled after it's being come out of metallurgy and it's all ready to go, to take it over to staging to where it'll pour into the casters. You know, when you get to the top there, I mean, you know, heat rises, right? So when you're in the top of the steel mill and all that heat from all that molten steel is up there, you know, they say the temperature at that part of the mill is anywhere between 130 to 135 degrees. I've never been in 135 degree temperature for a period of time. And so you get up there and you realize, and I mean, I'm just drenched. I mean, I'm just like somebody took a water hose over my head. And I remember I turned to the camera, it said, without heat, there's no new steel. Without heat, there are no highways. Without heat, there's no hospitals. Without heat, there's no school. And the reference I'm making here is that heat is a good thing, because without it, we're not melting steel. And without that, think about our daily lives. It would be Civil War, horse and buggy. Our hospitals would look like a field hospital at Gettysburg. Log cabin, dirt floor, and a wood table. We get to the top to where the crane operator is. You know, thinking, wow, I got the day before to work on the virtual reality program of how to handle, you know, a crane in a steel mill.
Yep.
Joysticks, yep.
Okay. There you go, sir. Ready to go.
What's the up button?
Okay,
Come on. Oh shit, now we're helicoptering. Damn it. You guys are happy I don't work in the mill. I get it. I get it. Am I killing your guys' bonus or what, man? The swivel. You see, I didn't know this. I mean, you guys want to attract talent. Let them come tell people out there, hey, 18-year-olds, come play with this. So that was so cool. Thanks, guys. Jerome, thanks, man.
no problem. That's cool.
But now to sit in the cab with the gentleman who was doing this. He was talking to us, well, welcome. I'm going to go pick up a ladle full of molten iron, and we're going to move it over here. And it just hits you. This is real. This is intense. All right, what are we doing, Mike?
We're about to go take a full heat to the caster.
Oh, I love it.
It's probably 180 to 190 tons. It's almost 400,000 pounds.
So when this lift comes, it's almost 200 tons in total between molten steel and the ladle weight itself. And Mike here is going to show us how that's done. The good news, I don't get to do this.
It's a blind view, so they'll have to tell me when I'm hooked up. I can't see a whole lot.
Wow, that's crazy. He was so intense and so focused as he looked down, and all he was doing is using his hands on the different levers to maneuver, to get the hooks in place, to lift that ladle, to maneuver it inside the mill all the way to its place, to where it went into its position so it could feed the caster, where they could tap the bottom of it and it would feed into the caster. Well, we didn't say a word. This was 10, 15 minutes.
You got it, Mike. Take it away.
Houston, Tranquility Base. The Eagle has landed. Day 4, what we were doing because of the timing on Sunday, day 4 was Monday, so we got to see the steel being made into the billet form, and that's where we stopped our tour on Sunday. So you go and you see these billets, you see the overhead cranes coming in, and you know they're loading these racks and these automatically these billets that are, you know, that have cooled down. They're not completely cold, but they go into this furnace. They call it a reheater, and it heats them up, and it comes out that glowing orange and red, and it goes through the various machines. And you're actually seeing a 6-inch tube, solid square tube, well, not tube, it's a solid square of steel going in and being manipulated by these machines to where it gets down to rebar that can be only this big around. It can be even this small, or big number 18 rebar that might be that big. And you're watching this and you're seeing all this hot steel being molded down, and it's going all the way down the line where it's being made into rebar. "60-foot strands of rebar. And then it goes into this cooling table that automatically moves it and then it goes into the binder. It's really an incredible experience, and it's fully automated. And you're seeing it, they measure it, they cut off the extra ends that are too long, and then it's being bundled. Then it's being picked up again by another overhead crane operator that's being stacked into the different racks of rebar, all the different sizes, because you don't know who needs what for construction purposes. So we get out into their yards where they have the metal stacked in piles that they use to melt. And got a real education from the team there about what percentages of metals of iron they're using to create the melt. So we go over and we see the shredded material that came from the shredder that was across the street. You're using what percentage of shred?
So on a typical day, anywhere between 30 to 40% shred is what we can run.
Per charge?
30 to 40% total weight.
Okay, so let's use 40, let's use the high end. 40% shred. How much plate structural?
I'd say on the plate side, probably 20. Cut grade, by then you'd be at about 15 to 20% there too. So your remainder is going to be your reclaim, borings if you're going to be using that, tank tracks, which you can use those interchangeably.
And they say, well, we use about 30% shredded material. So that goes into the furnace, and then you go to the pile of heavy recycled iron, and that's called plate and structural, the PNS as they call it. Well, the PNS grade is heavy beams that have come from something that has a structural center, be it plate from a ship. But then you got this heavy torchables like this for the plate structural. So this is a high value commodity. And when people call it junk, doesn't it just make your skin crawl? I mean, it just drives me crazy.
Well, I see a high value commodity there.
But see, people don't see that. And this is part of the education process I think Repurposed provides is this is what the future infrastructure looks like. This is what your future military looks like. It's what your hospital looks like.
Absolutely.
Without this, we don't have that. But there's different products that, you know, from fabrication shops that have leftover plate, leftover tubulars, leftover I-beams. They're like a chef. You gotta use a little bit of this and a little bit of this and a little bit of this, and that's what creates the blend. Sierra Recycling and Demolition, we process iron every day. We provide cut grades. And at the steel mill, there's the shredded grades, there's the torch grades of plate and structural, there's the cut grades that could be plate and structural, and HMS #1. So we're part of that chain. Sierra's part of that chain of processing metal for a steel mill. But when you see it firsthand and you get to talk to them, you get a real appreciation of the equipment that is needed to process all this metal. The investment, these individual facilities across America, millions of dollars that they have to invest in equipment to process this material. Tell us more about the technologies that CMC's employed and our industry's employing to make the steel we need every day for our lives.
This is the fun part of what we do every single day. So we are commissioning a state-of-the-art, it is the first ever merchant micro mill that has ever been built in the world. And we're doing that today. And if you look behind the steel making process, there are banks and banks of computers that are processing the steel, that are helping facilitate the steel making process. I mean, the loops, the feedback loops, the technology that's employed in those mills. I mean, this is not manually controlled things. These are automatic, fully censored. I mean, it's like your new cars today. I mean, the sensors are everywhere.
Okay, so after day 4, we left Seguin, Texas. We go to Houston, Texas to go see Commercial Metals steel fabrication shop that really has everything to do with rebar, sizing rebars to all the different orders. And you see this warehouse that's just, you know, automated with you know, the machinery that moves rebar, stacks it, cuts it, bundles it, does everything to fill orders for construction sites. Because not at a construction site that we will see the next day, you realize there's so many different sizes of rebar and how they need it is completely different. Some needs to be bent, some needs to be straight. They need number 6 rebar. They may need number 11 rebar, all the different sizes. It's done at fabrication shops, and Commercial Metals, because they're fully integrated, they're vertically integrated, they have their own fab shop that is fully automated that processes the rebar to the different sizes and lengths and forms that construction contractors need for their construction projects.
And on this board, actually, we saw one, the customer that put it all these electricals, which is center point.
Oh, okay, wait a minute, hold on. So we're coming kind of to the end of the tour of the facility, and all of a sudden I look, and you talk about being distracted by something, because it just hit me right then and there. And all of a sudden it threw my day completely in a way that I had never even thought about. All right, Eloy, that 18 bar and this electrical grid here, that's the foundation for each and every of these poles.
Yes, sir. That's exactly right. We thread them on our equipment, on our machine. The customer put it outside. He built a massive cage, they did a massive hole only for that one with a big crane. They lift it up and they put it right in that big hole.
How many feet down is it going? You know?
It was a good 40 feet or so.
Here were these huge 300-foot tall towers for the electrical grid right behind this facility. And above ground was about 3 feet of concrete.
We're talking about you from here to here and the whole radius.
That's crazy.
It's about 30 feet to 40 feet
in the ground.
When
you talk about the electrical grid in this country, and you see every one of those power lines and the structure that supports it, it never dawned on me that underneath every one of those structures is concrete, and every one of those concrete foundations has rebar cages in them that comes from recycled iron. And we're not talking number 6 rebar, we're talking number 18 rebar that's this big around. It is huge. When you go home and you turn your light on, America, if you don't have the foundation, if you don't have the rebar supporting all this electrical, you're not turning on your light. All right, so Eloy, you're telling me this tower is about 200 to 300 feet. So if you lay it down,
sir.
That's a football field.
Yes, sir.
And this rebar, you know, in the final fab we saw being made yesterday in Seguin and on Saturday in Durant, this rebar is being made from recycled iron. I mean, the visual here for me is just so, it's exciting because look at this. Look how far this electrical, and this is just one section. This is America. We have to electrify America. All the factories, all the automotive industry that making cars that we drive, right? How about all the food plants making our food? All those foundations start with rebar. You're electrifying America, you need steel. And that steel, the rebar to build the foundations to all the electrical structure is made from recycled iron.
They need it.
And CMC is playing a monster role in electrifying America. Yeah, you gotta love it, buddy. So when you're sitting there and you see these towers, these steel structures, as far as the eye can see to the north, as far as the eye can see to the south, and even off to the east. And these towers are holding the power lines that are bringing the power to the city, to the houses, to the grocery stores, to the hospitals, to the schools, to the airport, to all the things needed. And you realize none of it is possible. And it hit me like a ton of bricks, or maybe like a ton of metal, if you will. That without recycled iron, you don't have rebar. And it takes rebar to reinforce every one of those towers along the electrical grid. So this power grid that is made from recycled metals isn't made from waste, because you can't make this from waste. Raw materials that supply the steel mills, the copper foundries and aluminum foundries to make the electrical infrastructure comes from the recycled materials industry. And for what we saw just in Houston, it just hits me. Wait, this is all over America. This is North and South America. This is Europe. This is all over the world. Rebar is the backbone to the electrical grid. Day 6 in Houston of this trip. We get up, we have to be on the road by 6:15 in the morning to drive to this construction site. And in this construction site, it's a 6-story building with an underground garage and everything. And we're gonna see this construction project, and we're gonna get to see the rebar that is open, that has yet to have concrete poured on it. And we're seeing this construction, and then you realize, again, you're touching it with your hands and your feet. Floors, each floor is reinforced by rebar. The walls of this concrete building, reinforced by rebar. And then the steel structure of the building, the big beams that hold this structure together from a outside structural standpoint, they came from steel mills in America that were making it from recycled iron.
Without rebar, the access to rebar, the access to concrete, you don't see these buildings. These buildings aren't going up. There is no alternative form of construction for buildings of this nature or of this size. You can only get so far with timber. You can only get so far with unreinforced concrete. Rebar is an absolute necessity, and without it, you wouldn't be able to build these structures.
Here in Houston at this incredible construction project, and when you see the vastness of this project and you're walking the floors and all the reinforcement and the concrete being used in this facility, it doesn't happen without rebar, and rebar doesn't happen without recycled metal. But the vastness and all the steel in this project, and you know, that's the backbone of America, steel. Because without steel, construction projects just don't happen. And this facility is absolutely incredible. And if you look at the equipment and all the metals that are around here that it takes to build this facility, you get a new respect for what it is the recycled materials industry does. How many truckloads of rebar are we looking at, Rebecca?
This is 4 truckloads on this pour right here.
Just on this pour?
Yes. Just on this pour.
Yes, 4 full trucks.
80 tons.
Yeah. 1 pour.
We just got done with the walk and talk. It's loud, it's hot. Give me the behind the scenes grit of why this isn't easy to do.
Any construction project has so many moving parts, and there were this one machine that's something to do with concrete demo, you know, they got to fix something up, and it's loud, and you got people walking all around, and you know, you're walking on top of a rebar mat and it's over there. You got to watch your step. what we do is supplying the raw materials for like CMC, making all this rebar, and it takes 1.5 years to estimate a project, and all that goes into it. And here we are, we're 2 years into this construction project, not quite 2 years, and you start seeing it come together, and you see the exposed rebar, but you see all the concrete and all that rebar that's in it that's no longer exposed. People will never understand how a building like this is built until we start peeling back the layers like we are on this project.
And when you think about this construction site, it's incredible what our industry is doing for America. These people who are investing millions of dollars to build this 6-story structure, they had purpose, they have vision, they're the entrepreneurs of the world, right? But you're not going to do it without rebar. So day 7, we start out to go to see some structures in Dallas, famous structures. The Margaret Hunt Hill Bridge over the Trinity River.
I'm here with Rodney Scott. Rodney, thanks for joining me today because
That's a pleasure.
You are a supplier of rebar and steel products for construction projects for highways, bridges. That is your expertise, man.
That's it, 30 years.
You know, we're looking at this bridge, but what people don't see is what's below this bridge. Tell us what the hell's below it and how did we get here?
Well, exactly. What you see the strands, you see the towers, you see the suspension product, but what you don't see is the reinforcing steel that from the abutments to the column to the shaft. Some of these shafts go 50 feet deep.
It's an incredible bridge, you know, an engineering marvel. But what's interesting, it's all made from steel. But what you don't see, again, this is very interesting because, you know, by day 7 of filming, you really get the understanding that what's important, you're not going to see.
So those gigantic cages, they're 50 feet down below?
50 feet down below. We have some that go deeper than that. They have to hit rock for them to really stop.
What goes into the construction of these bridges, and then you're never going to see, is what supports these bridges.
And like I said, what you don't see is how many bars are in these columns. So you'll have possibly 20 to 30 bars that are held together by what they call a stirrup, a rebar stirrup, that ties them all together. The drill shaft contractor comes out, punches the hole, they drop the shaft in there. Then they have rebar dowels that stick out the top so they can connect to the columns or connect to the abutments to hold everything together so nothing moves.
We're on the bridge, we're walking back. We just got to stop and talk about this. Look at this. This tower is pretty damn tall, pretty heavy. What's going into the foundation here and for this tower?
Well, in a foundation like this, you're probably talking another 40 to 50 feet to get down where you really need.
This tower is made from steel too.
It is.
Chances of it being recycled iron is pretty doggone high, isn't it?
Probably about 100%.
Boy, am I looking over here, I am seeing hundreds of towers. And without recycled iron, we don't make this.
Well, they never stop. If you think about it, think about electric poles, electric cable, they never stop. I mean, it's just one constant flow of electricity.
Well, as America grows, cities grow, the infrastructure for the cities requires road, electricity, sewer. So much recycled content into it. Rodney, we had to stop here and talk about it.
And all the different footings, the pillars that go 60 feet into the ground on this river to support that bridge. And all of that concrete is reinforced by rebar. And then all the steel that's used in the manufacturing of that bridge. And you think about that and you just say, that is a necessity for this country. The rebar that goes into the building of bridges in this country paramount to the success of the structure. You can't build it because the structure is going to fail.
This is an incredible engineering feat, but it all starts from a CMC rebar that you guys put into this project.
Exactly.
The steel industry is the backbone of a country's independence. Would you agree with that?
I absolutely would. You know, if you look at the steel industry, it stands behind just about every aspect of our economy and is critical to having it move forward. And that goes from everything from construction, where we play a big role, to transportation, to any type of equipment and machinery for manufacturing. It's absolutely essential to what we do.
We don't get to the foundation of who we are as an economy, what the important things are as an economy, and when we get down and we start looking at things like grassroots recycling, I mean, it's right in front of people. Every single day it's right in front of people, and for whatever reason they land on that runway that's got steel in it. They don't ever think about how it got there, right? We don't think about, we take so many things for granted. I mean, we're transforming this stuff efficiently, quickly, and we're putting back into the society. We're putting it right back into society.
Rebar is literally the foundation to American infrastructure. Because without it, we don't have it.
On the next episode of Repurposed.
This is not waste. This material that you see behind me, this is the raw material. This is the commodity that EAF steel mills like SSAB, like CMC. These steel mills use cut grade irons along with shredded iron that we saw from the shredders to make the blend they need to make new steel.